Let's take another problem which is asked in GATE 2007. So engineering mechanics GATE AME 2007. First I will write the problem. During inelastic collision of of two particles, which of the following is conserved? Which of the following is conserved? That is number A, total linear momentum only. Linear momentum only. B, total kinetic energy only. C, both linear momentum and kinetic energy. Both linear momentum and kinetic energy. D, neither linear momentum nor kinetic energy. So I will just give some of the theory part for understanding the elastic collision and inelastic collision. So let's take elastic collision. Elastic collision. In elastic collision, during the collision, the energy will remain conserved. The reason is that in elastic collision, there will be no loss of energy in terms of heat energy due to the impact of collision of the bodies. So in elastic energy, the energy will remain conserved, and of course, the elastic collision in which the net force is acting on a body is zero, so the linear momentum will also conserve. So for elastic collision, I can write linear momentum will be conserved, and there is no energy loss due to the conversion of energy into heat energy during impact or collision. So we can say that kinetic energy will also be conserved. So that is the conditions for elastic collision. Similarly, in inelastic collision, in which the sum of the energy will convert into heat energy due to the collision or impact, means the kinetic energy in case of inelastic collision will not be conserved. But of course, in inelastic collision also the net force acting on the system will be zero, so linear momentum will be conserved. So we can write the conditions for inelastic collision: linear momentum will be conserved, but the kinetic energy will not be conserved. So I can write kinetic energy will not be conserved. So in given problem, it is mentioned that is inelastic collision. So we can say in elastic collision only the total linear momentum is conserved. So correct answer will be A. So remember one thing, the conditions for elastic and elastic condition will differ in terms of conservation of kinetic energy, but the linear momentum in both the cases will be conserved. Now let's take another great problem, which is asked in GATE 2007. So GATE AME 2007. It's a very interesting problem. So first I will write the problem. A block of mass capital M is released from point P is released from point P on a on a rough inclined plane with inclination angle with inclination angle theta shown in figure. The coefficient of friction is mu. If mu is less than tan theta, then time taken by the block to reach another point Q on the inclined plane where PQ equals to S. So now we have to find out the time taken by the block to reach another point Q where PQ is S. So now I will draw the diagram for our clear understanding. Here angle is theta. This one is the point Q. Here we are having the block at point P, and the mass of the block is given M, and this distance PQ, that is S. So now we are interested in time T. So for solving this problem, first of all we will draw the free body diagram and we will see what are the forces are applied parallel to the plane, and according to this force we will find the acceleration. And then it's a problem of motion with uniform acceleration, so we'll apply the three equation which is based on motion with uniform acceleration, and we will find the value of t. Now let's draw the free body diagram of the block M. This one is the block M here. This one is the inclined plane which is making an angle theta. If you see, this one will be the mass weight of the block, that is mg. You see there will be a two component of this, that is along the plane, that is mg sin theta. This is perpendicular to the plane, it will be mg cos theta. And here the frictional force will act in upward direction because block is moving in the downward direction, it is mu r, and this one will be the reaction. So now this one is the free body diagram of this block, where along the plane there are two forces mg sin theta and mu r perpendicular to the plane r and mg cos theta. So perpendicular to the plane the body is in equilibrium. So I can write on perpendicular to plane body is in equilibrium. So for our understanding I am writing the conditions of equilibrium, that is algebraic summation of all forces acting perpendicular to plane on body will be 0. So we are having two forces R here and mg cos theta, both are acting in opposite direction, and now the body is in equilibrium perpendicular to the plane, so I can write R equals to mg cos theta. So now along the plane we have to find net force. So net force along the plane. So net force along the plane which acts on body. Which acts on body. So if you see body is moving in that direction, means along the plane, that is the motion. So mg sine theta is one force and mu r acting in opposite direction. So net force will be mg sine theta minus mu r. So F is net force mg sine theta minus mu r. So we know the value of r. If we put here, we will get mg sine theta minus mu mg cos theta. So now we can easily find out acceleration along the plane. Acceleration along the plane, because we know the force acting on a body is mg sine theta, that is capital M, sorry, minus mu mg cos theta. So if you want acceleration, it's nothing but force by mass, that is force by mass. So mg sine theta minus mu mg cos theta divided by mass. So we will get g sine theta minus mu mg cos theta. And if we take g cos theta common, so I will get tan theta minus mu. So here, sorry, we are having g sine theta, that is mu g. So we will get g cos theta into tan theta. That is the acceleration. Now I will again draw the plane here. So block is here at a point P and we have to reach the point Q. So PQ is given, that is S. And now we know the acceleration, that is M. It is uniform acceleration. So I can use the equation S equals to 2t plus 1 by 2 at square. Here initial velocity is 0. So S equals to 1 by 2 at square. So t will be twice s by a. So square root of twice s by a. Now 2s in place of a, I can write g cos theta into tan theta minus 1. So now we will get final t equals to under root of 2s divided by g cos theta into tan theta minus 1. So this one is the desired expression t in terms of s, g, theta. Another problem of GATE examination 2005. Here GATE NE 2005. Here I am writing the problem. The time variation of the position of a particle in rectilinear motion, is given by x equals to 2t cube plus t square plus 2t. If v is the velocity and a is the acceleration, of the particle in consistent unit, then find V and A. So now we are interested in V and A. So now let's solve this problem. This problem is a problem where motion is not uniformly accelerated motion, means this problem is based on motion with non-uniform acceleration. So here instantaneous displacement is given. So now we have to find out instantaneous velocity and acceleration. So definitely we will use differentiation for finding velocity, and then we will use differentiation of velocity for finding acceleration. So let's take a displacement that is 2t cube plus t square plus 2t. So now here in this problem we are interested in find V and A at the time of starting of motion. Starting of motion. Because you have to specify at which time you want V and A. So now velocity is denoted by V. It is nothing but dx by dt. So we have to take differentiation of this 2 into 3t square plus 2t plus 2. So V will be 18t square plus 2t plus 2. So at the time of starting of motion, means at time t equals to 0, V will be 18 into 0 plus 2 into 0 plus 2. So V will be 2. So the velocity will be 2. Now similarly acceleration is nothing but rate of change of velocity with respect to time. So we are having the velocity 18t square plus sorry, here it will be 6 sorry, so it will not affect our results because it is ultimately 0. So here it is 6t square plus 2t plus 2. So acceleration is 12t plus 2 plus 0. So acceleration will be 12t plus 2. So at t equals to 0, acceleration will be 12 into 0 plus 2. So we will get a equals to 2. So the correct answer v equals to 2 and a equals to 2. Now let's take a problem of GATE in 2005. So I am just writing the problem for engineering mechanics GATE in 2005. First I will write the problem. A simple pendulum of length 5 meter with a bob of mass 1 kg is in simple harmonic as it passes through its mean position. The bob has a speed of 5 meter per second. The net force on the bob at the mean position. So here in this problem, a simple pendulum of length 5 meter is given. The mass of the bob which is connected to the string of the simple pendulum is given, that is 1 kg, and this is in simple harmonic motion. So when it is passing through the main position, the speed of the bob is given 5 meters per second. Now we have to find out the net force on the bob at the main position. So let's solve this problem. So I will draw a diagram where the bob is in main position. Suppose this is the point where the string is attached. On the other end there is a bob. Now it is in main position. This one is the main position. Main position. So here in main position velocity is given, but if you see the forces which is acting on the main position, here the mass of the bob and here tension T. So now it is in equilibrium. It is in equilibrium, so the net force will be T minus mg. But if you see the magnitude of T, which is equals to mg. So now from equilibrium equation, from equilibrium equation, we can write T is to mg. So net force acting on the bob at mean position will be T minus mg or mg minus T. So it will C because T equals to mg. So mg minus mg will be C. So the correct answer is C. Another problem which is asked in GATE 2005. In GATE ME 2005. First I will write this problem. A shell is fired from cannon at the instant the shell is just about to leave the barrel its velocity relative to the barrel is 3 meters per second, while the barrel is swinging upward with a constant angular velocity 2 radian per second. The magnitude of the absolute velocity of the shell is. So now in the problem, a shell is fired from the cannon. At the instant when the shell is just leave the barrel, its velocity relative to the barrel is 3 meters per second, while the barrel is swinging upwards with a constant angular velocity of 2 radians per second. Now we have to find out the absolute velocity of the shell. So I am now here just drawing the diagram. The hinge support. This one is the barrel here, and the direction, the relative velocity of the barrel, direction of the relative velocity of barrel here. It is 2 radian per second mentioned, and this one is 2 meters. So So this one is the diagram given in the problem, and now we are interested in absolute velocity of the shell. So let's assume absolute velocity of shell is v1 and absolute velocity of barrel is v2. And now we are having relative velocity of shell with respect to barrel will be v1 minus v2. So now we are having these things, that is absolute velocity of shell is v1, absolute velocity of barrel is in v2, relative velocity of shell with respect to barrel is v1 minus v2. So this one is nothing but v1 minus v2. And now the barrel is moving in an anticlockwise direction. So the linear velocity at the time of exit here will be v2. So now we can easily find out the value of v2 because angular velocity is given. So we know the relationship between angular velocity and linear velocity. So v2 will be omega r. So v2 we know the omega 2 and radius is nothing but this distance 2 meter. So v2 will be 4 meter per second. So now we are having the value of v2. So v2 here is 4 meter per second. And v1 minus v2 also we are knowing that is relative velocity of the shell with respect to the barrel, that is 3 meter per second. So now if we suppose this point is B, and if I draw the vector diagram again at point B, so I am having this 3 meter per second is nothing but v1 minus v2, and I am having here v2 that is nothing but 4 meter per second. So now if I draw the vector diagram, or I will use the triangle law of forces. So according to triangle law of forces, on application of triangle law of forces, triangle law of forces. So I can draw O. This is v1 minus v2. This one will be v2, and if we join this point to this point, well, this one will be the v1. So now v1 by the triangle law of forces we can easily find out the value of v1. So it is nothing but resultant of these two, that is v1. So now we can easily find out v1 is nothing but v1 minus v2 square plus v2 square. So v1 equals to v1 minus v2 is nothing but 3, that is relative velocity of shell with respect to barrel. This v2 we already calculated, it is 4. So 3 square 9 plus 4 is 16. So we will get 25. So v1 will be 5 meter per second. That is the absolute velocity of the shell. So the correct answer is 5 meter per second.